All right, guys. So we're gonna continue solving log excuse me, log equations today. Last time we looked at solving like basic ones. You don't need to write this, but like we started by solving something like this. That's just like a basic one. The idea there is you're gonna exponentiate both sides, right? That's the basic idea. Then we looked at some problems where like we had extra stuff, like maybe there was some numbers inside the log, or maybe there was some numbers outside the log, and we had to solve those kinds. And then a third kind that we looked at last time was ones where you have logs on both sides of the equation. These ones, you remember we had to do something special for those ones. You have to look to make sure that your answers actually work. So you could actually get an answer that's false there. So we're going to be continuing to solve log equations. We talked about those three, and we're going to vamp it up now and talk about some other types here. You don't need that, but just put 10.9 at the top of your paper. That's okay. All right. So here is example 1, but actually let me do that. All right. So this is example 1. Go ahead and copy that down. See if you guys can identify what makes this equation kind of different from the other ones we've seen so far. So maybe if you noticed it, what it is there's two logs that are being added together. Okay, so we're going to talk about how to handle that situation. So how to handle or how to solve problems with log plus log. What we're going to do is we're going to put them together into one log using that property that we learned a little while ago. You can put these together into one log if you multiply the two things that are in the log together. Okay, so that's the idea there. So in this case I've got x plus 9, and in this case I've got 6. We're going to multiply those together, so let's do that. X plus 9, I'm going to keep that in parentheses because it's a binomial, times 6, and we're going to distribute that 6 inside. Okay, so these two logs here can come together to make log base 4. By multiplying these two things together, we get 6x plus 54. That's the new step. Okay. After that, there's not much different from what we learned on Friday. So that's the big idea. So how do you solve problems with log plus log? You multiply those two parts of the log together. Okay. So from here, we would exponentiate. Okay. So I would use a base of 4 to get rid of the log. It's going to be a big number. These things cancel out. Leaves me just with 6x plus 54. On this side, 4 to the 4th power, I think it's 256. And then from there, I think you guys know we're just going to solve. So It doesn't go nicely. Okay. Now what we can do is we can reduce it though. So both. Thank you for checking that, by the way. What goes into both of these numbers is at least 2, right? They're both even. So I'm going to reduce, and I get 101 over 3. Just make a note here. Reduce by 2. Right, there it is. So everything from here down was old news. It's just that first step that was new. Okay? Okay, let's do another one here. This is I'm gonna make this a plus though. I don't want that to be a minus. So go ahead and write that down. Give you a second there. Alright, so I want you guys, I'm going to ask somebody to tell me what goes here. So see if you can figure out what goes there, and I'll call on someone to share what they think goes there. And exponentiate. So I'm going to use this as my base. And we're going to do it to this side also. Okay. So after I do that, Jessica, what would be left on this side? $20x, yeah. And how about on the other side? So basically just these things go away. And then from there we're just going to divide. Alright, so we'll throw one at you guys. Try one on your own there. Alright. Let's see what you guys got. There you go. Try that one. Give you a second. Alright, so that's a fourth type of log equation that we looked at today. So how do you handle situations where logs are being added? So now we're going to move into a fifth type, which is where they're being subtracted. So let's do that. So go ahead and write this one down. We'll call this example 2. All right. So for example 2, we're going to talk about how to handle or how to solve with log A minus log B. So it's subtraction. What we're going to do is we're going to put those together into one log by dividing these two things. Okay. I'll wait a second. Okay, so for this one I can put these two into one log. If I take this thing and I put it in the numerator, and this thing and I put it in the denominator. That's it. That's pretty much the new step. There is some other interesting algebra things that will come up along the way, but that's the new step. So let's go ahead and do the next step, which is to exponentiate both sides. So I would use a base of 4. All right, these cancel out. 4 to the first power is just 4. So I'll wait there. So this is where some interesting algebra stuff will come in. Catch up with me and I'll show you the next step. So, little note worth writing here is so at this point with these fraction problems, you're going to have to multiply both sides by the denominator. Like that. And on this side, the denominator and the x you're multiplying by cancel out. So that leaves me with x plus 1 on the left side. And on the right side, I got 4x. So in this problem, we have x's on both sides. So what you need to do in that case is subtract or add or whatever to get rid of the x's on one side. So I usually like to get rid of the smaller one. So I'm going to get rid of this x here on the left. I'm going to subtract it. And whatever you do to one side, you do to the other. Think of that as a 1. 4 take away 1 is 3. And then after that, we just divide. Okay. So the main new step is when you have two logs that are being subtracted, you make a fraction out of it. But when you get down here to this step where you have the fraction equal to a number, you're going to solve it by multiplying both sides by the denominator. Those are the two big ideas there. So I'll throw one your way. See what you guys can do there. All right, so we've talked about 5 different log equations, right? The basic ones, the one with a whole bunch of extra numbers, one with logs on both sides, ones with pluses, one with minus logs. This next one's not going to look different at first, but it is. And you can't see why it's necessarily different just by looking at it here. But what's going to happen is that it's going to end up being a quadratic. Okay, so let's write this on the side. How to handle quadratics. Remember what a quadratic is? Give you a bonus point if you can tell me. All right, so quadratic is anything with an x squared. Okay, so we're going to have an equation with an x squared in it. The way that we solve this is we will use factoring. So this is kind of like the one that's probably the most tedious of all the problems because there's just a lot more math involved when you're dealing with quadratics. They're a little more tedious. Okay, so let's go ahead and see what we can pull off here with this. All right, so first of all, notice that I'm adding these two logs. So my first question was going to go to Amaya. If I'm adding these logs, what will I do with these two things here? We're going to multiply those. And to multiply these, since they're both binomials, we're going to have to use the box method. Okay? So I'll show my work here on the side, but just to remind you of how to do the box method to multiply, we have x minus 5 is my first one and x plus 7. So we're just going to multiply to fill in the box. So x times x is x to the second power. X times negative 5 is negative 5x. 7 times x is 7x. 7 times negative 5 is negative 35. So we have x squared we'll combine these two together because they're like terms. 7x take away 5x is 2x. And then minus 35. So I'll wait there. So that's the first thing. You might not have to do the box. It just depends. If you have two binomials like this, you'd have to do the box. But if you have a monomial and a binomial, you just distribute like we did last time. But you could end up having to do the box there. Now, remember I said for this problem, we're talking about how to handle quadratics. A quadratic is something with an x squared. So you guys see now, you can't see it in the beginning, but you see now there is an x squared there. So this is a quadratic problem. All right. The next step is we're going to exponentiate both sides. So 8 log 8 these cancel out, and I'm left with x squared plus 2x minus 35 equals 64. Now, with quadratics, at this point, we need it to equal 0. When it comes to quadratics, they have to be equal to 0 to solve them. So I don't like that 64 over there. I want this thing to equal 0. So what can I do to make this equal 0? I can get rid of the 64 if I just subtract it, yeah. So you'll probably just have to add or subtract to get rid of that number over there. But this is going to be, now it's 0. That's going to be negative 99. So now I've got x squared plus 2x minus 99 equals 0. All right. At this point, we're going to factor. So there's 3 terms. When you factor that, you're going to use a box method for that. So the first term goes here. The last term goes here. And our job is to find out what numbers go here. So what times what makes x squared, you guys? So that's definitely x and x. What times what makes 99? 33 and 3 is a good guess. That's true. Let's go with something else. 9 and 11 works also. Now, which pair do you think would give me 2? 9 and 11. So let's go ahead and go with 9 and 11. And one of them has to be negative. Notice that I want the middle number to be positive. Which one do you think should be negative to get a positive in the middle? The 9, yeah. So we have negative 9x, positive 11x, and sure enough, these do add up to make the middle, so we're in good shape. Okay? So what we have then is x plus 11 and x minus 9 equals 0. So let's take a breather. We're almost done. Step 1, we just added them, right? We multiplied to commute 1 log. We exponentiated. We need, since this is a quadratic, we need it to equal 0, and then we factored. Now we're ready to solve. So we'll set this one equal to 0. We'll set this one equal to 0, and we'll solve both. I get negative 11. And I get 9. So the little note I would add here is for quadratics, we need to check our answers. Once again, your answers cannot make the logs have a negative on the inside. So let's try this. If I were to plug in negative 11, what does that make? Yeah, so that makes negative 16, right? You can't have a negative in there. So that means this is not a solution. We cross that off. What about 9? If I were to plug in 9, that was my other answer over there. Would that be okay? Yeah. Both of these come out okay. This is a positive 4. That's a happy situation. And that's a happy situation. So 11 is a false answer. We throw it away. 9 is a real answer, so we'll circle that and call that our answer. So there's 2 times you have to check your answers. Quadratics, and what's the other one? We learned it last time. If there's logs on both sides of the equation, you check your answers there too. Okay, so there's that. I'll throw one up here for you guys to mess around with as I come around and check your notes for the day. See how far you guys can get with that guy.